Welcome back to our Math 171 video series. In this video, we'll learn the method of partial fractions, which we'll use to simplify a more complicated fraction. The fraction we're going to try to separate into partial fractions is x minus 3 over x squared minus 6x plus 8. Our first step to splitting this fraction is going to be to factor the denominator. We'll notice that denominator is second power, and so we'll try to split that into pieces. Since this is a second power denominator, we can expect two pieces. We'll try to think of two numbers that multiply to make 8, but add to make negative 6. The sets of numbers that could multiply to make 8 are 8 and 1, or 2 and 4. If we added 8 plus 1, we would get 9, which is not a match. If we take 2 plus 4, we will get 6, which is also not a match, but it's the right number with the wrong sign. We'll just change our signs to negative 2 and negative 4, and that will give us negative 6, which is a match. Therefore, we can split this second power expression into x minus 2 and x minus 4, because those are the numbers we could add together to make negative 6. Now we will rewrite our fraction with those pieces as the denominator. If we do so, we will have x minus 3 as our numerator and x minus 2 times x minus 4 as our denominator. Also bear in mind that since we have two pieces in our denominator, we can expect two partial fractions, which we will label a and b. So we'll write fraction a plus fraction b. On the bottom of a, we'll write the first piece, x minus 2. Underneath b, we'll write the second piece, x minus 4. Our goal is now to solve this rational equation and find a and b. We'll take this rational equation and move it to the next page. To solve a rational equation, we'll begin by finding the LCD. You may notice our first denominator has two binomials, x minus 2 and x minus 4. Therefore, our LCD must contain those binomials. We also notice that we have an x minus 2 in fraction A and an x minus 4 in fraction B. Therefore, we have no additional terms other than those two binomials. Therefore, we'll say our LCD will equal x minus 2 times x minus 4. We can also set the LCD equal to 0 to find the restricted values. We will say x minus 2 times x minus 4 is equal to 0. We'll set each piece equal to 0 separately. For our left piece, x minus 2 equals 0, and therefore x would equal 2 if we move the 2 to the right side. We'll do the same thing with the negative 4. If we move the negative 4 over, we'll have x equals 4. Now that we have the restricted values, let's multiply all of the terms in the rational equation by the LCD. So our first fraction will get an x minus 2, x minus 4 in the numerator. We'll do the same with all of the other fractions. Now we'll see what cancels. In the first fraction, we have an x minus 2 on the top and the bottom, and an x minus 4 also on the top and the bottom, meaning the only thing left of the first fraction is x minus 3. In the second fraction, x minus 2 will cancel out. However, the x minus 4 will still be there, and we'll have capital A times x minus 4. We'll do the same thing with fraction b. The x minus 4 is on the top and bottom, and it will cancel, leaving us with plus b times x minus 2. Now we'll use this equation and the x's that we just found, x equals 2 and x equals 4, to try to solve. Now we'll use our new equation and the x's we found from the LCD to attempt to solve for a and b. We're going to begin by plugging in one of the x's we found. When we plug in one of the x values, what we're going to find is some parts of this equation will cancel, and it will allow us to solve for either a or b. We're going to start by trying x equals 2. We'll rewrite our equation, then replace all of the x's with 2. Every position that was x, I have now replaced with the number 2. Now we can simplify. On the left, we'll have 2 minus 3 is negative 1. And then we'll have a times 2 minus 4, that's negative 2. And you may notice that we have b times 2 minus 2. 2 minus 2 is 0, and so the entire b term will cancel. Now, when we solve for a, we can just divide both sides by negative 2. Therefore, we will end up with a equals 1/2. That's one letter down. Now let's try the other x. Our other x was x equals 4. We'll rewrite our equation, but now instead of saying 2, we'll say 4 in each of the x positions. We've replaced all of the x's with 4, and now we'll have 4 minus 3 on the left, gives us 1. A times 4 minus 4 will give us 0, because 4 minus 4 is 0, times a will cancel completely. And then for b, we'll have 4 minus 2, which is 2, times b is 2b. Now we divide both sides by 2. When we divide both sides by 2, we'll end up with b is equal to 1/2. Now that we have our a and our b, we can write our partial fractions. Now we'll place the a in the a position and the b in the b position. So our partial fractions are now 1/2 over x minus 2 plus 1/2 over x minus 4. Now notice our answers are compound fractions, and so to simplify these compound fractions, there's one more move we can make. When you have compound fractions, the denominator of the top can move to the bottom. This means this 2 can move to the bottom. When we move that 2 to the bottom, we'll place parentheses around the x minus 2. We will do the same thing with the other 2. Therefore, when we rewrite these fractions, we now have 1 over 2 times x minus 2 plus 1 over 2 times x minus 4. This will be our new set of partial fractions. And so this is how we take a fraction and split it into 2 partial fractions. Thank you for watching. We'll see you again soon.